And welcome to my calculus clinic. This is Dr. Ghada Nakla. Today we will be looking at how to apply integration by parts. Integration by parts is very special. You have to have one of the terms as u, and the other term would be the derivative of v. And the answer would be u multiplied by v minus the integration of v du by dx dx. So this is what we'll be learning today. We'll be looking at applying this. One of the other things that we need to know is how to identify u. U is always what comes first of the word late. L stands for logs, or ln, the family of logs. A stands for algebra. T stands for trig. E stands for exponential. So let's try and apply this into to one of the questions. And our first question we're going to look at is the integration of x sine 2x dx. And you are asked to use differentiation, integration by parts in order to integrate this. So the first step, as ever, we are going to identify u, and we are going to identify dv by dx. And as I said earlier, v is the first that comes out of the word late. L stands for log. X is not a log, sine 2x is not a log. Okay. Second letter is A, and we're looking at algebra. X is definitely algebra, so U is X. It follows then that sine 2x is dv by dx. So one of them is U, and one of them is the derivative of v, dv by dx. Okay, so the answer would be u multiplied by v minus the integration of v du by dx dx. Now, before we apply the rule, let's differentiate u with respect to x. So du by dx. When you differentiate x, you get 1. This is x to the power of 0. You decrease the power, so the 0 will disappear. The 1 will become 0, and x to the 0 is 1. So it will disappear. It will all become 1. And then you integrate. In order to find v, you will have to integrate. As you've seen from one of the other videos, this is the y, positive y axis. So it's sine. Positive x-axis is cosine. Minus sine, because the negative y-axis. Negative x-axis is minus cos. And we integrate this way. If you watch my other videos about differentiation, we differentiate from the other side, from this side here. But today we are integrating, so we're going the other way. So we are integrating sine, and to integrate sine, you get cos minus cos. So if you're integrating sine to x, you get minus 1 over k, k is 2, cos kx. So it's minus a half cos 2x. Then we apply the rule. We apply the integration rule, which is u times v minus the derivative of v du by dx. So the integration of this, that is equal to equals u times v, which is x minus x over 2 cos 2x minus the integration of minus a half cos 2x multiplied by 1 dx. which is v times the du by dx, dx. Let's tidy things up and integrate. So minus x over 2 cos 2x. Minus minus is a plus, so plus. Kick the half out of the integration. Leave the half alone, and let's integrate cos 2x. Let's go back to here and see, when we integrate cos, you get what? Sine. So you're integrating cos kx, so you are going to get 1 over k sine kx plus c. And then we can tidy this up a little bit, so it's minus x over 2 plus cos 2x, sorry, cos 2x plus a half times a half, 1 over 4 sine 2x plus c. And let's leave it there. Let's take a look at the next example. And this time I'm integrating ln of x dx. And I need to use by parts in order to integrate. Okay, u, I need to identify u and dv by dx. So u is the first that comes out of the word late. L stands for logs, ln's. Can we spot ln? And there is one there, so ln x. Now, what is dv by dx? dv by dx is the invisible 1 that we can find here. So it's 1 ln of x, or 1 times ln x. So it's 1. So dv by dx is 1. Let's differentiate and integrate. So we need to find du by dx. And when you differentiate ln x, you get 1 over x. Then we integrate to find v, we integrate dv by dx. And when we integrate 1, the 1 is the same as x to the power of 0. So increase the power. When you integrate, you increase the power, divide by the new power. So it's x to the 1 divided by 1. Increase the power, divide by the new power. And x to the 1 is the same as x, isn't it? Now, let's finish it off by applying the rule. So it's u times v. So this one is equal to u times v, so x ln of x, minus the integration of v du by dx, so x times 1 over x dx. V multiplied by du by dx. I'm applying the rule, and the rule is in the formula book. You don't need to memorize it. Then I'm going to finish it off by integration. Let's simplify this. I can actually simplify this. So basically I'm integrating 1, which is easy. So it's equal to x ln x minus integration of 1 is x plus c. And that's my answer. Let's take a look at something slightly different. Example 3. And this time I'm integrating x squared e to the x dx. And I'm using by parts to integrate. First thing, I need to identify u. U is the first that comes out of the word late. L stands for logs. I can't see any logs. The next one is A. A stands for algebra. Can I spot any algebra? X squared, definitely. Therefore, dv by dx has to be the other term, and the other term is e to the x. And then the next step is to differentiate and integrate. So I'm going to find du by dx. When you differentiate x squared, you get 2x. You drop the power and then decrease the power of the x. Because I'm differentiating with respect to x, you decrease the power of the x. So 2 minus 1, which is 1. So it's x to the 1. And when I integrate e to the x, I get e to the x. E to the x does not change. Next, I apply the rule. U times v minus the integration of v du by dx. So let's apply it from here. This is equal to u times v, so x squared e to the x minus the integration of 2x e to the x dx. Okay, now how am I going to integrate this one? This one is slightly complex. I'm going to use by parts again in order to integrate this one. So I'm going to have a u as u will be the first that comes out of the word late. I can't see any logs there or ln. So I'm going for algebra, which is 2x. dv by dx is e to the x. Du by dx, differentiate. So I'm going to get, when you differentiate 2x, you get 2. Decrease the power of x, this is x to the power of 1. Decrease the 1, it becomes x to the 0, and x to the 0 is 1. Integrate this one, so v is equal to e to the x. When you integrate e to the x, it stays the same. Then we apply the by parts rule. U times v minus the integration of v du by dx. So let's go back here and let's say equals from here. This one will stay the same. So I'm going to have x squared e to the x because this part does not need to change here. Okay, minus. I'm going to have a pair of brackets because this minus is going to affect what's inside it, what's inside the brackets. So I'm going to go u times v, so 2x e to the x, u times v minus the integration of 2 e to the x dx. And I'm going to close the bracket. So it's u times v, so 2x times e to the x minus this branch here, which is minus the integration of 2e to the x dx. And these pair of brackets are really important because they're going to affect our signs in a minute. So let's leave this one alone. X squared e to the x minus 2x e to the x. And then minus minus, this will become a plus. And I am integrating 2e to the x. I don't integrate the 2. The 2 stays the same. It's a constant. When I integrate e to the x, I get e to the x plus c. So I'm going to have x squared e to the x minus 2x e to the x plus 2 e to the x plus c. And I can take e to the x common factor, but yeah, I'm just interested in applying it rather than simplifying things further.